Hi everybody, welcome to my very first video blog post. I've decided today to look at a tool called SQLMap, which is an open source penetration testing tool that automates the processing and exploiting SQL injection flaws. So, before jumping in and having a look at SQLMap, let's first have a look at this demo website that I've built. It's a simple shopping website that, if we have a look, happens to be mountain bikes and other accessories. This demo website has been built on top of the AdventureWorks 2012 database, so all this data that you're seeing here has been generated for me. One important thing to note though while looking at this website is that we can see that the category ID is being passed in as a query string parameter. Now this will be important when we come to have a look at SQLMap now. So to get SQLMap running, you also need Python 2.7 installed on your machine as well. If you haven't got this installed, both SQLMap and Python can easily be found from a search engine. So, let's run SQLMap and get started. So here, you can see that I've given it the URL of that products controller that was on our website, and then passing it in the subcategory ID query string parameter as well. So let's run SQLMap and see what happens. So there we can see that SQLMap is connected to the target URL, and that the web server has responded with a HTTP error of 403. Now, this isn't unexpected, but let's try and continue with the test and let's see what we can get out of it. So here, SQLMap has then tried to determine what the back-end database was, but has been unable to. Now this could mean many things, but we can also see that towards the bottom here, that it received a 403 forbidden error 84 times, which to me would mean that most of the tests failed that it tried to do. A common reason for this could be if the web application is running behind a WAF, which is a web application firewall. We can quickly tell this by asking SQLMap to identify the WAF. So here we go, we can see that now SQLMap has been able to identify that this web application is running behind Cloudflare. So, we've got a couple of options here. One of them is to use the random agent parameter. Now this will actually allow SQLMap to be able to do its job and to try and test the website for any vulnerability flaws. And how it's going to do this is actually by just randomizing the agent string that's passed to the website, so Cloudflare won't see this as an attack. So it's asking us to continue. We do. Here it's been able to identify that the parameter subcategory ID is dynamic, and it's been able to quickly identify that we're running on SQL Server. Now this is pretty much correct. I'm actually using the Azure SQL databases for this, so we're going to say yep, let's carry on skipping the other tests and run. And it's saying, do we want to include all the tests for SQL Server? Yes, let's go ahead and do that. So, while these tests are running, I'm actually just going to pause the video. So welcome back. In the 30 seconds or so it took to run, SQLMap has correctly identified that the subcategory ID is indeed vulnerable. And it's asking us, do we want to continue testing? For this, I'm just going to say no for the moment. The reason is I want us to actually be able to get some tables back now and actually get some data that we could actually use maliciously if we wanted to. Also, we can see that SQLMap has identified that the operating system was Windows and it was also running ASP.NET 4. So let's run the command that we did last time, but yet give it the tables and schema options. And let's see what SQLMap can bring back for us now. Like we did before, we're going to continue even though we know that this application is behind a WAF. So SQLMap has finished running. Let's have a look at the output from it. I'm just going to scroll as far back as we've got in this console. And here, we can see that it's identified that there's two databases, one called TempDB and one called AdventureWorks 2012. Now, the AdventureWorks 2012 database is indeed the one behind our web application. So here we can see that it's been able to identify some of the table names, anything from department to employee to shift and to job candidates. Now, all this has been done from just a single command from our part. And the whole point of this blog post was just to prove how easy SQL injection flaws can be detected, especially from people just using simple programs that are point and shoot. Now, if we actually do carry on though through the output from SQLMap, we can actually see that it's been able to identify some of the columns. So for example, this is the virtual file stats summary table in TempDB. But if we continue, we can also see that it's been able to identify some of the columns from the AdventureWorks database as well. Now that we've got this information, anybody wanting to do anything malicious to this website could try to update any of those tables. They could try to drop any of the tables or the databases if the user does have permission that's running the website. But really, the possibilities are endless. So that's it for my very first video blog post. But do go ahead and test your own websites for SQL injection flaws using tools such as SQLMap. Thanks everybody, and do give me your feedback. Cheers!